Mr. Ahmed here. We have finished up week 1 of our distance learning and on to a short week for week 2. Our goal for this week is going to be to review factoring. The purpose of us reviewing our factoring is going to be to help us solve our quadratics. Like we said when we factored, that was the main purpose of us factoring. So when we factor our process, the first thing that we always want to do is we want to look for a GCF. If there's a greatest common factor, we want to pull it out. So GCF stands for greatest common factor. After that, if there's no GCF to pull out, we're going to look at the quadratic and see if the TLC, the leading coefficient, is equal to 1. So that is the case when we have x squared with nothing in front of the x squared plus 4x, and let's see, what would be a good example for that, plus 4. This would be a case where we could factor when the TLC is equal to 1 because it's just x squared. When the TLC is greater than 1, that would be our next case, we would use the AC method. That's when the x squared has a coefficient, so something like 2x squared plus 6x minus 8, something like that. Use AC method. That's the long one. Okay, and then we have our special cases. PST stands for perfect square trinomial. And then DS is another perfect case. That's the difference of two perfect squares. So we're going to go through an example of each type of these factoring methods. The first one, GCF. So we're looking for a greatest common factor. If there is a greatest common factor, we want to pull that out first. So our first example says 3x squared plus 9x. Greatest common factor for those would be obviously 3. And the lowest exponent for the variable, we have an x squared and an x, we can take out a 3x. So 3x goes outside the parentheses, divide both terms by 3x. 3 over 3 is 1. X squared over x is x. And then 9 over 3 is 3. The x's cancel. X plus 3. Now, if you were to distribute this back out, you'd end up with the same exact thing. Check your work. 3x squared plus 9x. Okay? Factor out the GCF. Number 2, GCF. What goes into 4 and 2? 2 does. Lowest exponent for the variable is an x to the second, so our GCF is 2x squared. We're going to take 2x squared out. So 2x squared goes outside the parentheses. When we divide, 4 over 2 is 2. X to the fifth over x to the third. Subtract the exponents. 5 minus 2 is 3. X to the third is our goal. And then 2 divided by 2 is 1. And the x squareds cancel, so we still have to have our 1. And you could always check your work by distributing it back out. Factoring out the GCF, that's always what we look to do first. Second method, TLC equals 1. So this is when we just have an x squared, no coefficient for the x squared. All right, so first example, we have x squared plus 6x plus 8. We practiced this a bit last week. We're looking for factors of the last term that add up to the middle term. So the factors of 8 that add up to 6. Factors of 8, let's see here. I got 8 and 1. I also have 4 and 2. When I look at the signs, the last sign is positive, so they have to be the same. Middle's positive, so they're both plus. Setting up my two sets of parentheses, x times x gets us x squared. So x times x first, unfoiling. Plus, plus. Our factor pair that adds up to 6 is 4 and 2. So we have an x plus 4 and an x plus 2. You could FOIL it out to check your work. Next one, we're looking for factors of 50, and it's a negative. Factors of negative 50, so that means we have to have a plus and a minus. X plus, x minus. Keep in mind when you're working on your assignment that sometimes it might be a z, it might be a c. Use the correct variable. In this case, it's an x. All right, so factors of 50. Let's see here, I got 25 and 2. 25 minus 2 is 23, that don't work. 10 and 5. Let's see here, 10, 5. It has to add up to negative 5, so that means we have a negative 10 and a positive 5. Negative 10, positive 5. We have factored the trinomial. The next method is by far the hardest one. That's the AC method. And that's when our leading coefficient is not 1. So we have a number in front of the x squared. In this case, we have 2x squared. So when I use the AC method, we multiply the first and the last term. 2 times 21. 2 times 21 is 42. So AC equals 2 times 21. A, this is B, C, 42. Now we have to find factors of 42 that add up to 13. So what times what is 42? 6 times 7. 6 times 7 is 42, and those add up to 13. So now I rewrite. First term still 2x squared. Now we're replacing our 13x with a plus 6x and a plus 7x. Our 21 is still there. Now we factor by grouping. What's the GCF of the first two terms? I can take out a 2 and I can also take out an x. 2x out. Left inside is x plus 3. Second two terms, GCF of 7 and 21 is 7. There's only an x here, so I'm taking out a 7. It's a positive 7. Left inside, x plus 3. Notice our two sets of parentheses are the same. So to finish our process, take what's outside in the first set, 2x plus 7. And the second set is the one that was common, x plus 3. We have factored it. Okay, one more AC method. Then we'll go on to our special cases. So, A times C. 6 times negative 3 is negative 18. We are looking for factors of negative 18 that add up to 7. So that would be a negative 9 and a positive 2. Negative 9, positive 2. Oh, that's negative 7. So positive 9, negative 2. 9 minus 2 is 7. So rewrite the middle term, 6x squared. We're using these two numbers, plus 9x, minus 2x, last term's minus 3. Factor by grouping. First two terms, GCF is 3x. When I pull 3x out, left inside, 6 over 3 is 2x, 9 over 3 is 3, plus 3. Now this one starts with a negative, so I have to take out a negative 1, which will change the signs to a positive 2x and a positive 3. Notice the parentheses are the same. They have to be. Take what's outside, which is 3x minus 1, times the common set, 2x plus 3, factored using the AC method. Those ones are the tougher ones. Our special cases always involve perfect squares, okay? So our perfect squares. So we're looking for perfect squares. When I use these, the square root of 4, x squared is 2x. Square root of 9 is 3. Keep in mind, we have to multiply these two together and double it to get the middle term. 2x times 3 is 6x. Double it, that's 12x. We got it. So when I do the special case for the perfect square trinomial, 2x plus 3, those were the perfect squares. Square root of the first term, square root of the second term, and it is squared. If you rewrote it, it could also look like 2x plus 3 times 2x plus 3. Okay? So we did a few of those. Look for the perfect squares. When you see some really big numbers on these problems, odds are it's a special case. So again, square root of 36x squared is 6x. Square root of 25 is 5. Multiply the two together and double them. That's our middle term. 6 times 5 is 30. Double it. That gets us our 60x. So in our set of parentheses, 6x plus 5 squared. We have factored the perfect square trinomial. Okay? And lastly, the difference of perfect squares. Two terms, minus sign in between. Square root of 9x squared is 3x. Square root of 25 is 5. 3x plus 5, so we have a plus, and we also have to do a 3x minus 5. Difference of perfect squares, one of our special cases. And the last special case, square root of 100 is 10. Square root of x squared is x, so we have square root 10x. That's a perfect square. Square root of 49 is 7. 10x plus 7 times 10x minus 7. Make sure you have the plus and the minus. This only works if it's a difference. If I had two perfect squares such as x squared plus 100, that is not a difference, so I cannot factor it. That's prime. Okay, it has to be a minus sign in between the two perfect squares. So that's a good little video for our factoring review. Use this as you're working on your factoring problems during our short week. Have a good one.